So we are done with the chapter. Let us come back and start with your board papers. So board papers, let us start with your 2017 paper. As you have seen, I've done all the questions, right? And please check the playlist for the answers. And we very well know the weightage for the chapter is 3 marks. So here they've given us A, B, C questions, or question again has 3 marks. So multimolecular associated colloids I've done in the playlist, which is named under video number 23. And next, coagulation and peptization I've done in video number 18, coagulation, and video number 25, peptization. Then homogeneous and heterogeneous catalysis, they've asked me the differences. So video number 4, you have that difference between homogeneous and heterogeneous with an example also. So when I go to the OR question, they've asked me to write DP, dispersion phase and dispersion medium of milk. So I've done in video number 21 different examples. I asked you to practice the table also, so please go to the table. And next, when I come back to this question, write one similarity of physis option, chemis option. Okay, I did differences and similarity also. 10, I have totally of 10 differences. In that, 9 were differences, 1 was similarity. Please watch that video. That is numbered as video number 2. Next would be write the chemical method by which ferric hydroxide salt is prepared from ferric chloride. I've done this question video number 27. So please go to the video, that is hydrolysis reaction. So by the method of hydrolysis, I've prepared ferric hydroxide salt as well as aluminium hydroxide salt. So let's come back and do your 2016 paper. Hope you watch the video. Go simple. Go to the playlist, your surface chemistry playlist. In that, you all are numbered directly. Go to the particular number and please prepare your own notes. Next, students, do one more session of your board papers. So today we've already done the 2017 paper. Let's come back and do 2016 paper. So in 2016 paper, they've given one question here, and they've also given 1 mark questions. That is 3 questions. That is for 3 marks, and this for 1 mark. Let's see. What did they give us? What is the reason for the stability of colloidal salts? So basically, when stability is asked, you can speak in terms of 3 important concepts. What are they? You can either speak in terms of charge, right? So they said colloidal particles, they remain like that. They're stable. They don't they speak in terms of the presence of the colloidal particles. So when do that happen? When the like charges repel, isn't it? So if it is opposite charges, they come together and they get attracted and coagulate. So simple answer you can write as reason for stability is, you can write like charges repel. This is one reason. Then you can also write about the stability can be explained by Brownian movement also. This is also one more reason which I explained you already. One more reason for stability of colloids, any one can be written. One more reason for stability of colloids is basically solvation. What is solvation? I'll tell you. So when I have to speak about solvation, done. So solvation is basically attraction between the solvent with the molecules and ions. Nothing simple. So I'm going to write attraction between solvent molecule, that is your dispersion medium, with the molecules or ions. That's it. This is solvation. So when they attract with the dispersion medium attracts with the molecules or ions present in the colloidal salt, then automatically they retain that stability. You can write any of one reason can be done, right? So when I have to answer the remaining questions, define the following terms. Lyophilic colloid, I did it in video number 22. Zeta potential, I did it in video number 17. And associated colloids, I did it in video number 23. Please watch the videos. Let's come back and do 2015 paper. 2015 paper, let's read this question. What do they give us? Give reasons for the following observation. Physis option decreases with increase in temperature. Very simplest question. We'll try to answer in 2 lines. Done. So physis option decreases with increase in temperature, they said. Okay, let us see what is physis option basically. Suppose if I have a solid, then this solid is an adsorbent. Now you have the base, right? Now you have a gas which is an adsorbate. Done. Now when gas goes to the surface of the adsorbent, this will go and get adsorbed and forms gas on the surface solid, plus lot of heat is released. Okay, now this is reaction which is in equilibrium. Now observe carefully. Now on the surface of the solid, you have gas which has adsorbed, and finally it has formed gas solid, and this is sorption. That is your attachment. Now they said physisorption decreases with increase in temperature. Now when I am proceeding in this direction, now what happens? Now they said you are increasing the temperature. Now according to Le-Chatelier's principle, what is the concept? Whenever you are increasing the temperature, yes, the system adjusts itself in such a way that it reaches to a new equilibrium. That means when you are proceeding in this, now see here the lot amount of heat which is generated, that means you are increasing the temperature. Now when you are trying to increase the temperature in this direction, what does the system do? You know, immediately it will shift and its equilibrium to the backward direction. It will try to attain that stability by following or adjusting itself in a other direction. It will attain a new stability now. So once again, according to Le-Chatelier's principle, whenever there is increase in temperature, the system adjusts. Now this is your system. The system adjusts itself, or it attains a new equilibrium state or new stability in such a way that it means it will go in the opposite direction. So now what happens? We have come in this direction. When it attains a new stability or new equilibrium state, again gas solid will become gas and solid is separate. Now see, physisorption decreases. Is it not again decreasing? Both are separated. Yeah. When you increase, both are together. When you decrease, both are separated. That is why physisorption decreases with increase in temperature. So write that sentence and write in words. I am repeating again. According to Le-Chatelier's principle, when temperature is increased, the system tries to adjust itself by attaining a new stability. Means it will adjust itself in such a way that it attains stability. So what state is that? It will go back and gas and solid are separated. Hence physisorption decreases with increase in temperature. Please write that sentence. I don't have place, and that's why I'm not writing it. Now, adsorption of alum purifies water. So what is alum? Alum is basically a form of clay, isn't it? Yes. What is it acting in water? It's used for purifying water. So alum acts as coagulant. So what does it do? This alum, it will go or it will absorb, I'm telling absorb. It will absorb all the fine particles or small dust particles or whatever the impurities of the smaller size are there. Everything goes and attaches on the surface of alum. Is it not acting as coagulant? Yes. So what does it do? It acts in a coagulant and absorbs smaller dust particles and sand, and larger particles, whichever are heavy, will settle down in the tank, and they are separated by filtration. So you can write addition of alum purifies water means alum acts as a coagulant. This is a keyword which is present in the marking scheme. What does it do? It's going to pull out small dust particles, will go and attach in the form of, because it is just like a clay. When they absorb, the remaining heavy stones or rocks, bigger stones like smaller stones like pebbles also, they settle at the base of the tank, and those are removed. So this is how you're going to write your answer. Next question, Brownian moment provides stability to the colloids. I did this in video number 15. Please watch that. And here, what is the method by which lyophilic colloids are coagulated? I did this in video number 19. Please watch the video for the information. So 2014 paper, again you have a 3 marks question and 1 mark question. So let us read the first question. What is the effect of temperature on chemisorption? So we very well know whenever you are increasing the temperature, adsorption increases. Yes or no? Because it's going to form chemical bonds with the adsorbent. Done. So most important thing is chemisorption, rise in temperature, it favors adsorption. That is the first important thing. And when I have to speak about chemisorption, yes, as the temperature is increased, number of bonds will increase. When the number of bonds increases, the concept of chemisorption also increases. So let us write the answer. How should I write? A rise in temperature increases adsorption. Done. So what about chemisorption? As I said, chemisorption or formation of chemical bonds. Done. So chemisorption increases with temperature. That's it. Simple. 2 lines, because it is only for 1 mark. Half mark for this, half mark for this. So let's come back and do the next question. What are emulsions and what are the different types of emulsions? Give one example each. I've given a complete detail of emulsions where I've explained about oil and water type, water and oil type, what are emulsifying agents, what is de-emulsification, all these. So I've done in this video, which is numbered as video number 30. Please watch the video, practice the whole video for 3 marks, because 3 marks, because maximum is 5 marks. For 3 marks you need to write the complete answer. Please watch the video for the complete information on emulsions. Do your 2013 paper. Again, here they've given you one question, 1 mark question. In 1 mark question, again they've given a choice like this. So let's read. Write the dispersed phase and dispersion medium of the following colloidal systems. They've given me 2 examples, smoke and milk. So in this video number 21, I've given a table rather, where I've explained you the interaction between dispersed phase and dispersion medium, taking different examples, right? Please go watch that video. You have to remember the whole table. As I already said, any example can be given and you are supposed to write the dispersed phase and dispersed medium. So watch that video which in the playlist, that is video number 21. Let's come back. They've given us what are lyophilic and lyophobic colloids. Which of these salts can be easily coagulated on addition of electrolyte? Okay, I have done a video based on nature of lyophilic and lyophobic colloid. I also asked you to remember this word, that is IRS. Remember that, IRS, not Indian Railway Services. IRS, I also said intrinsic, reversible and stable. In that way, I have also explained which is coagulated by an electrolyte in video number 22. Please watch that video. Done. After that, they've asked me to write the differences between physisorption and chemisorption. Okay, this was my second video after introduction video, but here what did they do? You're not supposed to write all the 10 differences, but you have to write specifically based on specificity, which I did, temperature dependence, which I did, reversibility, yes, I did that criteria also, and enthalpy change. So you have to divide the page into 2 equal halves, write the subheading and write the answer for that. So for that, please watch video number 2. Done. So I'm done with this. Please go back to the video, watch the playlist. For me, the main reason is I don't want you to lose even a half mark also. That is my concept. So come back and do 2012 paper. And do your 2012 paper. So again here, but in 2012 paper they've given 2 marks here and 2 marks here, to basically 4 marks chapter. So in earlier in 2017 paper, 2016 paper, 3 and 1 bifurcation was there. Here 2 and 2 marks. Let's read. Name the 2 groups into which phenomenon of catalysis can be divided. Okay, so give an example of each group with chemical equation. Here I've done the classification of catalyst, that is the catalysis process, that is homogeneous catalysis and heterogeneous catalysis. And after that, I've again given a flow chart with 1 example for everything, all types of catalysis. So you watch this video number 5 for this answer. Please practice that video completely. You have the whole information, so you have to practice with the reaction. That is why they've asked, see here, 1 reaction for each example, each group. You will be very careful. Please watch that video, which is numbered as 5 in the playlist. Next question. Explain the following with 1 example each. Again, they've given missiles. So the same grade 10 question repeated in grade 12 also. So watch video number 31 where I've explained the structure of soap, a structure of missile, so the hydrophobic end and the hydrophilic end. I also showed how do they align in soap water, how do they align in the water which contains dirt or grease, and after that I explain how should you write the reaction also, which is a negative missile. Please watch that video on video number 31. And aerosols. So this is basically in the video which is numbered as 21, where I have taught you classification of dispersion medium, classification based on the interaction between or the type of dispersion medium and the dispersed phase, the particles in dispersed medium and dispersion phase. So I have given the thumbnail also the same title. Watch that video, that is video number 21. So let's come back and do 2011 paper. I think I have done almost all the questions. I've covered every question of the board paper. Let's come back and do 2011 paper. Let's come back and do your 2011 paper. In 2011 paper, they've asked us to define electrophoresis. So I've done this video in video number 19. So there's one interesting question here. Let's do that. They've given us, explain how the phenomenon of adsorption finds its application in each of the following processes. Okay, that's the reason I asked you to read the applications of adsorption. So let us apply. Simple. Basically, this is given for 1 mark. They asked me, use the adsorption concept or show the application of adsorption concept in this. So production of high vacuum. So how are you going to write this? Suppose let us assume you have, okay, you find the silica gel also, isn't it, in your, when you buy your new footwear, you find small silica gel bags dropped into that, or when you buy your thermos flasks inside also you have a silica gel bag or silica dropped into that, even charcoal also, it's the same like that. So basically when I have to speak about high vacuum, I have to relate the adsorption concept with vacuum. See, how am I going to write production of high vacuum? I am writing this answer here, just see. So this is done now. So production of high vacuum, what are you going to write? When I take charcoal, okay, charcoal has a lot of pores on its surface, isn't it? So what does this do? Charcoal tries to absorb the air. When does it absorb air? When I'm supplying high vacuum in that particular thing, and that high vacuum will make or allow the air or dust particles to settle on the charcoal. So are we not using the concept of high vacuum? You're creating or producing the high vacuum so that on the surface of charcoal, your dust particles or smoke gets absorbed. So it's easy for us to remove it, isn't it? So how are you going to write? Charcoal on surface of charcoal. Okay, on surface of charcoal, what is getting absorbed? Air or smoke gets absorbed. Absorbed due to production of high vacuum. This is what you are going to write the answer. So you are going to show the concept of adsorption here. Let's come back. Heterogeneous catalyst. So basically, what is heterogeneous catalyst? I am writing the second question here. Right. So what is heterogeneous catalyst? When the reactant or the catalyst and the product are of different phases. Simple, isn't it? So let us pick up. Suppose if I have in heterogeneous catalyst, I am writing the answer here. Suppose I have a solid catalyst like this. Onto this solid catalyst, I am introducing gas. So what will happen? Gas will go, now heterogeneous concept is written here. So gas, gas is the adsorbate. This is one of the state, physical state. This is your catalyst is in the solid state. Done. So both are different. So heterogeneous catalyst is, now when you take the gas, when you allow it on the surface of a solid catalyst, what will happen? It will get adsorbed. When it gets absorbed, what concept are you speaking? You're speaking about adsorption. You're speaking about heterogeneous catalyst also. Okay, what is the conclusion? So you can write using the concept of adsorption. In heterogeneous catalysis, gas gets adsorbed on the solid catalyst, and as the surface area increases, more is the adsorption. You can also write that after this, more of the surface area, more is the adsorption. That is what you are going to write. Both relate heterogeneous catalyst as well as adsorption concept. Let's come back. They've given us froth flotation process. Okay, we have studied this answer in metallurgy chapter, how to relate with adsorption. So what is froth flotation? Basically, you're going to take a froth flotation tank. You're going to add stabilizers, collectors and all these, right? So what is the main role in that? You're going to remove sulfide ores. You're going to separate sulfide ores. So what is the concept of adsorption there? In froth flotation process, sulfide ores adsorb to the froth. This is the concept, isn't it? Sulfide ores adsorb to the froth, and all your impurities are present at the base of the tank and they are washed off. So this is the concept where I am using. So froth flotation process, you have to write the sulfide ore, and you also should write the word of adsorption, because they have asked how is the phenomenon of adsorption used. Here I have written in terms of charcoal adhering with air. Here I have written the concept of gas with solid catalyst. Here I have written the concept of sulfide ores adsorbing to the froth. brought and it is separated, and you add stabilizers also to make it stable. So this is how you are going to write the answer. Just write one word, don't write big paragraphs. It is only for 1 mark. Let us come back. There's one more question. Define micelles, peptization and desorption. Okay, micelles I've already done in video number 31. Peptization I did it in video number 25. Please watch that. So sorption is attachment, desorption means detachment or removal from the surface of the adsorbent. So just write desorption means separation or removal from the surface of adsorbent. I already said adsorbent is a base, adsorbate is a one which is attached on the surface. So removal of adsorbate from the adsorbent is called desorption. Let us come back and do your 2010 papers. Let's see. What is an emulsion? They've asked me. Okay, I did a complete explanation. I gave you a complete explanation of emulsion with definition, with types, emulsification agent, emulsifying agent, de-emulsification and properties of emulsions in video number 30. Please watch the video in the playlist. Let's come back. One more question. What is the difference between multimolecular and macromolecular colloids? Give an example for each type. How are associated colloids different from two types of colloids? Okay, I did one video where all the three, that is multimolecular, macromolecular and associated colloids are given in the same page. That is in that same video, same video, which is numbered as video number 23. So please watch the video. A clear explanation is given. Directly you can write that answer in the exam. So I'm done with both the questions. Let us come back and do your 2009 paper. What is coagulation process? So I have taught this in video number 18. Please watch that. Here I've also explained what are the different methods of coagulation. Yes. Now next question, what happens in the following activities? Why? They said an electrolyte is added to hydrated ferric oxide solution in water. Okay. So hydrated ferric oxide is nothing but ferric hydroxide. So I've already taught this concept as under peptization. So you're going to watch that video, peptization, and see how when an electrolyte like FeCl3 is added to ferric hydroxide, it finally forms charge. That's a salt, colloidal salt. So what are you going to write? A precipitate rather, not colloidal. You usually write it as a precipitate. Then you are going to write that this happens because of neutralization of charges. So once again, watch this video and end your answer like this. You can write because of neutralization of charges. Just write like that and finish off your answer. But watch that video. After writing that, whatever information is given in the video, peptization, then end your answer with that. Next question, a beam of light is passed through colloidal solution. Okay, they're asking me to explain the concept of Tyndall effect, which I did in video number 14. Next one, an electric current is passed through colloidal solution. So this is the concept of electrophoresis, which I did in video number 19. Please watch that video for complete information. Right, let's come back and see. In 2008 paper, they've given us what are lyophilic and lyophobic salts. Okay, done. Give an example for each of the type. Okay, which of the following two types of salts are easily coagulated? Yes, so I've done this in video number 22, but in second question I'll tell you how to write. Which one of these two types of salts is easily coagulated? Okay, so when I've taught you the differences between lyophilic and lyophobic salts, I asked you to remember one concept, that is IRS, right? I stands for intrinsic, R stands for reversible, S stands for stability. So among both, which is more stable? Lyophilic is stable, lyophobic is unstable, remember. So whichever is unstable will get fast, it will get coagulated faster. So what do they ask? Which of the two types of salts are easily coagulated? So the answer would be lyophobic. Why? Because it is unstable. That's it. You're going to write your answer like that. So watch that video, video number 22. Next, what causes Brownian movement in colloidal solutions? So I did this in video number 15 under the thumbnail, does Brownian movement affect the stability of colloidal salts? So watch that video for the information. Let's come back and do the last board paper, that is your 2007 paper. What do they give us? Explain the following terms, giving a suitable example in each. Okay, emulsification, the same question again. I've done this video in video number 31 where I explained you the definition. Again, I'm repeating the same. I've explained you the types of emulsions. Then I taught you the properties of emulsions. Then I also taught you what is the concept of emulsification. Okay, they were asked that. Please watch that. And de-emulsifying agents or de-emulsification also I've taught you. So please watch that video. I've given you listed out different examples for oil and water and oil types of emulsions. Next, homogeneous catalysis. So I did this in video number 5, where I've explained you catalysis is of two types, that is homogeneous and hetero. And again, homo is divided into subparts, hetero is also divided into subparts. So watch that video for that information. Next, come back. They've asked you to define adsorption and write any two features which distinguishes physisorption from chemisorption. Okay, that is done under video number 2. Please watch the video for the information. And define adsorption. What is adsorption? How do you define? It's basically the surface where your gaseous molecules or your liquid gets adsorbed in the surface of the solid adsorbent. So the attachment of the gaseous or the liquid adsorbates on the surface of solid adsorbent is called adsorption. Simple, remember, gaseous or liquids, that would be adsorbate. Where will that attach? They attach on the solid, which is the adsorbent. This is called adsorption.